Take a deep breath and feel the weight of your body settling into the mattress, letting the day's tension dissolve into the soft fabric beneath you. Close your eyes and imagine the gentle rustle of orange wings as the Danaus plexippus, the monarch butterfly, begins an incredible 3,000-mile journey across the North American continent. These delicate travelers are capable of navigating from the windswept fields of Canada all the way to the volcanic mountains of central Mexico, a feat of endurance that seems almost impossible for a creature weighing less than a gram. As we begin our journey tonight, imagine the air around you cooling to a perfect, crisp clarity, the kind of temperature that encourages deep, rhythmic breathing. In the quiet hours of the late summer morning, the Monarch prepares for its trek. To understand the Monarch, you must first understand the texture of its world. If you could reach out and touch the wing of a monarch, you wouldn't feel a smooth surface, but rather a velvet-like tapestry of thousands of microscopic scales made of chitin. These scales are arranged like shingles on a roof, each one pigmented with rich blacks and vibrant oranges. When the sun hits them, they don't just reflect color, they trap warmth. A monarch cannot fly if its body temperature drops below 55 degrees Fahrenheit, or about 13 degrees Celsius. It must wait for the first golden rays of the sun to touch its thorax, the central engine of its being, warming the flight muscles until they are supple and ready for the day's labor. As the sun rises, imagine the sensation of tasting the world through your feet. This is how the monarch experiences its environment. On the ends of their 6 legs are specialized chemoreceptors, essentially taste buds located on their tarsi. When a monarch lands on a leaf, it isn't just seeking a perch. It is tasting the chemical signature of the plant. They are searching for Asclepias, the milkweed plant. For the monarch, milkweed is more than food. It is a sanctuary and a chemical shield. As caterpillars, they consume the milky sap of the plant, which contains cardinolides, heart poisons that are toxic to most birds and mammals. The monarch stores these toxins in its own body tissues, carrying them through metamorphosis into adulthood. This is why their wings are such a brilliant, alarming orange. It is a visual whisper to the rest of the world, a signal called aposematic coloration, telling predators that this beauty comes with a bitter, dangerous price. The monarch's journey is not just a feat of strength, but a masterpiece of biological engineering. To navigate across such vast distances, they possess an internal sun compass located within their brains. This compass works in tandem with a circadian clock found in their antennae. Even as the sun moves across the sky throughout the day, the monarch's brain adjusts its flight path, calculating the angle of the sun relative to the time of day to maintain a steady southern course. Imagine the precision of such a mind, a tiny cluster of neurons capable of celestial navigation. And on cloudy days, when the sun is hidden, they rely on a magnetic sense, utilizing specialized proteins in their eyes called cryptochromes that allow them to perceive the Earth's magnetic field. They are, in a sense, seeing the very invisible forces that hold our world together. As you breathe in, imagine the air entering your lungs as easily as it enters the monarch's spiracles. Butterflies do not have lungs like we do. Instead, they breathe through tiny openings along the sides of their abdomen and thorax. These spiracles lead to a network of tubes called tracheae that deliver oxygen directly to their cells. It is a silent, passive way of breathing, an effortless exchange with the atmosphere. As the monarch lifts off, it beats its wings at a leisurely pace of about 5 to 12 times per second, moving at speeds of roughly 5 to 12 miles per hour. There is no rush in this flight. It is a steady, rhythmic pulsing, much like the beating of a heart in deep sleep. Think of the Methuselah generation, the unique cohort of monarchs that makes this long migration. While most summer monarchs live for only 2 to 6 weeks, this final generation of the year undergoes a biological shift. Their reproductive organs remain dormant in a state called diapause, and their lifespan stretches to an incredible 8 or 9 months. They are the elders of their species, the long-distance runners who carry the legacy of their ancestors across thousands of miles. Just like us, after a long period of activity, they seek the comfort of rest. When the sun begins to dip low and the shadows stretch across the fields, the monarchs begin to look for a place to roost. In the quiet hours of the evening, you might see them gathering in the boughs of a maple or a pine tree. They do not sleep alone. To stay warm and safe from the cooling night air, they cluster together by the hundreds or even thousands. They hang from the undersides of leaves and branches, their wings folded shut to reveal the paler, camouflaged undersides of their wings. In this state of rest, they are remarkably still. Their metabolic rate drops, their heart rate slows, and they enter a state of torpor. Imagine the feeling of hanging suspended in the cool evening air, surrounded by the gentle collective warmth of thousands of others, all breathing in unison with the forest. The physical sensation of being a monarch is one of lightness and intense sensitivity. Their antennae are constantly twitching, sensing the humidity in the air and the subtle changes in wind direction. They can feel the vibrations of a distant thunderclap or the approach of a summer rain through the delicate hairs on their bodies. When they drink nectar, they use a proboscis, a long straw-like tongue that stays coiled under their chin when not in use. When they find a wildflower, like a goldenrod or an aster, they unfurl this proboscis to sip the sweet, energy-rich liquid. It is a precise and delicate interaction, a moment of deep nourishment before the next leg of the journey. As we dwell on this image, consider the sheer scale of the landscape they traverse. They fly over the Great Lakes, sensing the vast humidity of the water below. They drift over the Appalachian Mountains, utilizing the rising thermals, warm columns of air, to glide and conserve energy. By hitching a ride on these thermals, a monarch can soar for miles without flapping its wings even once. There is a profound peace in that effortless glide, a total surrender to the currents of the earth. It is a reminder that sometimes the best way to move forward is to let the world carry you. The monarch's wings, though they look like paper, are incredibly resilient. They are made of 2 layers of chitinous membrane, supported by a network of hollow veins. These veins act like a structural skeleton, but they also serve a circulatory purpose, carrying hemolymph, the butterfly's version of blood, to the wingtips. If a wing gets a small tear, the monarch can often still fly, its determination outmatching its fragility. There is a softness to the way they move through the air, a gentle flick-flick glide pattern that is hypnotic to watch. It is the visual equivalent of a lullaby. As you find yourself drifting deeper into your own rest, think of the monarch's internal map. They have never been to the forests of Mexico before. The butterflies that started the journey north in the spring are the great-grandparents of the ones flying south in the fall. Yet, they know exactly where to go. This ancestral knowledge is encoded in their very DNA, a biological compass that guides them to the exact same groves of Oyamel fir trees year after year. They are following a path laid down by millions of years of evolution, a path of survival and beauty. In the quietest moments of the night, when the wind dies down and the world is silvered by moonlight, the roosting monarchs are a testament to the power of stillness. They are not doing, they are simply being. They are gathering the strength they need for the miles ahead. trusting in the cycle of the sun and the steady pull of the south. Their rest is not a lapse in their journey, but a vital part of it. Just like the Monarch, your body needs this time to settle, to repair, and to integrate the experiences of the day. The textures of the night are soft, the cool air against the bark of the trees, the dew forming on the edges of the milkweed leaves, and the weightless suspension of the butterflies as they cling to their perches. Each butterfly is a tiny miracle of biology, from the complex structure of their compound eyes, which contain thousands of individual lenses called ommatidia, to the delicate scales that give them their glow. They see the world in a way we can only imagine, perceiving ultraviolet light and patterns on flowers that are invisible to the human eye. To a monarch, a simple yellow daisy is a landing pad marked with intricate glowing nectar guides that lead them to the center of the bloom. As we prepare to explore further into their journey in the coming chapters, hold on to this image of the roost. The orange and black wings folded tight, the cool air of the evening, and the profound silent cooperation of a species in motion. You are safe in your own roost now. The world outside is continuing its ancient rhythms. The stars are moving in their courses, and the monarchs are resting, waiting for the warmth of tomorrow. Let your breath remain slow and steady, mirroring the quiet pulse of the resting migration. You are part of this natural world, a world that knows how to move, how to strive, and most importantly, how to rest. The journey of the monarch is long, but it is taken one heartbeat, one wing beat, and one quiet night at a time. Sleep now, knowing that the same forces that guide the butterfly across a continent are holding you here, in the quiet, in the dark, in the perfect stillness of the night. Consider the long-held mystery that once surrounded the autumn sky. For centuries, people living in the northern reaches of the United States and Canada watched the orange-winged travelers vanish as the leaves began to turn. They simply disappeared, as if dissolving into the cooling winds. It wasn't until quite recently in our human history that we understood where these delicate navigators were heading. Picture this: a scientist named Fred Urquhart, beginning in 1937, spent nearly 4 decades trying to solve this puzzle. He and his wife Nora developed a method of tagging the butterflies with tiny, pressure-sensitive labels, small white circles no larger than a fingernail, weighing only a fraction of a milligram. These tags bore a simple request: send to University of Toronto. Thousands of citizen scientists, from school teachers to backyard gardeners, helped tag hundreds of thousands of Danaus plexippus, creating one of the earliest and most successful examples of large-scale community science in history. The breakthrough finally arrived in January 1975. On a mountain peak in the Sierra Madre range of Michoacán, Mexico, 2 explorers named Ken Brugger and Catalina Trail looked up to find the trees literally dripping with gold. They had discovered the overwintering grounds at an altitude of approximately 10,000 feet above sea level. Imagine the silence of that moment, standing in a forest of Oyamel fir trees, known scientifically as Abies religiosa, or the sacred fir. These trees grow only in a specific, high-altitude microclimate, where the air is cool enough to keep the butterfly's metabolism slow, but not so cold that they freeze. Notice how the butterflies settle here in such densities that the branches of the fir trees, which are strong and sturdy, actually bow under the collective weight of millions of half-gram bodies. What's happening now is a masterclass in energy conservation. Before the monarchs even begin their southern trek, their bodies undergo a profound transformation. Unlike their ancestors who lived during the height of summer, these migrating butterflies, the Methuselah generation, do not focus on reproduction. Instead, they become specialized storage vessels. They feed voraciously on the nectar of autumn flowers like the New England aster and goldenrod, converting the sugar into lipids or body fat. Scientists have discovered that a healthy monarch can increase its lipid stores by up to 500% before and during the flight. This fat is stored in the abdomen and acts as a biological battery, providing the fuel needed to survive the winter months in Mexico when nectar is scarce. At this very moment, envision the monarch as a living kite, utilizing the physics of the atmosphere to glide through the sky. They are incredibly efficient flyers. Rather than constantly flapping their wings, which would deplete their energy reserves in days, they seek out thermals. These are rising columns of warm air created by the sun heating the ground. A monarch will spiral upward within a thermal, gaining thousands of feet in altitude with almost zero effort, then glide southward on a long downward slope until it finds the next warm lift. By using this soar and glide technique, they can cover between 50 and 100 miles in a single day. Think of the peace in that movement, a rhythmic rise and fall, carried by the breath of the earth itself. Deep within the butterfly's anatomy lies a sensory system that outclasses our most sophisticated technology. While we rely on satellites and screens, the monarch reads the hidden patterns of the sky. Their compound eyes are sensitive to the polarization of sunlight. Even on a hazy day, they can perceive the angle of light through the clouds, allowing them to maintain a heading of roughly 210 degrees, the southwest path toward the Mexican mountains. This is paired with their sun compass, a neural circuit that links the position of the sun with the internal time kept by their antennae. Scientists discovered through tethered flight experiments that if a monarch's antennae are painted with black ink to block out light, they lose their ability to navigate. The antennae are not just for smelling, they are the butterfly's master clock, ensuring they always know exactly where the sun should be at 10 a.m. versus 4 p.m. Consider the historical weight of this discovery. For the communities in the mountains of Mexico, the arrival of the monarchs has always been a significant event, often coinciding with the early November festivals. Long before the scientific world mapped the route, the local people observed the mariposa monarca returning like clockwork. They understood the butterflies not as specimens, but as a seasonal blessing, a shimmering fabric draped over the forest. This connection between human observation and natural cycles is a reminder of how we are all intertwined. Just like the observers of old, we find comfort in the return of these familiar patterns. Notice how the Oyamel forest acts as both a blanket and an umbrella for the resting monarchs. The dense canopy of the Abies religiosa traps the heat of the earth during the night, keeping the temperature within the cluster several degrees warmer than the open air. This is vital because if a monarch's internal temperature reaches 32 degrees Fahrenheit, the freezing point of water, the moisture on its wings could crystallize, causing fatal damage. However, the forest keeps them in a perfect Goldilocks zone between 35 and 55 degrees Fahrenheit. In this cool, damp air, the butterflies enter a state of reproductive diapause, a biological pause button. They hang in total stillness, their wings overlapping like shingles on a roof. This layered clustering is a cooperative survival strategy, a way of sharing warmth and protection that no single butterfly could achieve alone. Picture the texture of the forest floor during this time. It is often carpeted in a soft layer of needles and moss, which helps retain humidity. Moisture is one of the few things the monarchs need during their winter stay. On warmer days, when the sun manages to penetrate the canopy and warm the clusters to above 55 degrees, the butterflies will take flight in a cloud of orange to find nearby mountain streams or to sip dew from the forest floor. They use their proboscis to drink, a process called puddling, where they also intake essential minerals from the damp earth. Then, as the shadows lengthen and the temperature drops, they return to the exact same trees, often the exact same branches, to resume their rest. Scientists have used chemical fingerprinting, specifically stable isotope analysis, to trace where individual butterflies grew up. By analyzing the hydrogen and carbon isotopes within the chitin of a butterfly's wings, researchers can determine the exact latitude where that butterfly was a caterpillar. This is because the water and milkweed the caterpillar consumed carry a unique signature of the local environment. Through this method, we have learned that monarchs from the Midwest, the East Coast, and southern Canada all converge on these few dozen acres of mountain forest. It is a spectacular gathering of a continent, a meeting of travelers who have never met, yet have all followed the same invisible map. Consider the sheer resilience required for a creature weighing only 0.5 grams to cross the Great Plains. During their journey, they may face headwinds or rain. When a storm approaches, the monarchs sense the drop in barometric pressure. They immediately seek shelter, clinging to the underside of sturdy leaves or tucking themselves into thick thickets. They wait with a patience we might envy, remaining perfectly still until the pressure rises and the skies clear. There is no anxiety in this waiting. It is a simple mechanical response to the environment. They know when to push forward and when to settle back and conserve what they have. In the quiet hours of our own night, we can take a lesson from this biological economy. The monarch does not waste energy on unnecessary movement. Every wing beat is purposeful. Every moment of rest is a calculated necessity. They are not so different from us in their need for a sanctuary. Just as they find the Oyamel forests, we find our beds, a place where the temperature is controlled, the light is dim, and the outside world is held at bay. The historical journey of our understanding, from Fred Urquhart's first tiny stickers to the satellite mapping of today, mirrors the journey of the butterfly itself. It is a story of persistence, of looking closely at the small things, and of realizing that even the most fragile life is guided by powerful ancient forces. As you breathe, imagine the cool, thin air of the Mexican mountains, the scent of the fir needles, and the soft, almost silent sound of millions of wings shifting in the breeze. The forest is a place of deep, undisturbed peace, where time seems to slow down to the pace of a butterfly's winter heartbeat. You are drifting toward that same state of quietude, where the demands of the journey fall away, and only the stillness remains. The map is already written within you. The destination is rest, and you are arriving exactly where you are meant to be. Imagine the weight of a single paperclip resting in the palm of your hand. It is almost nothing, a mere fraction of an ounce. This is the exact weight of a monarch butterfly, usually between 0.25 and 0.75 grams. It is a staggering thought that something so light, roughly the same weight as a standard dollar bill, can possess the structural integrity to withstand the buffeting winds of a mountain pass. Picture this: the wings of the monarch, spanning between 3.7 and 4.1 inches, are not merely flat surfaces. If we could zoom in with a microscope, we would see that they are reinforced by a complex architecture of hollow veins. These veins serve as the butterfly's skeleton, but they also function as a hydraulic system. At this very moment, as a monarch rests, it may use abdominal pumping to circulate hemolymph, the insect equivalent of blood, through these tiny tubes to keep the wings pressurized and flexible. This is not so different from the way a modern aircraft uses hydraulic fluid to manage its flaps and landing gear, ensuring every movement is precise and supported. What's happening now is a transformation of energy that rivals the most efficient hybrid engines. To power their flight, monarchs rely on lipids, which are essentially high-density fats. Think of these lipids as a specialized, high-octane fuel that the butterfly stores in its abdomen. Scientists discovered that during the migration, the monarch's body becomes a living battery. While a summer-born monarch might have only a tiny percentage of body fat, the migrating generation can carry up to 125 milligrams of lipids. This fat is so energy-dense that it allows the butterfly to survive for months without a single meal. It is as if you could fill your car's tank once in September and not need to visit a gas station until the following April. This internal reserve is what allows them to endure the long, quiet winter in the mountains, where they remain in a state of suspended animation, burning their fuel at an incredibly slow, measured rate. Notice how the monarch's mouthparts are perfectly adapted for this energy intake. When you see a butterfly drinking, it is using a proboscis. Consider this tool as a pair of extremely long, flexible straws that are fused together. In the embryonic stage, the proboscis actually consists of two separate halves, called galli. As the butterfly emerges from its chrysalis, it must zip these two halves together to form a single airtight tube. If the seal isn't perfect, the butterfly won't be able to create the suction necessary to drink nectar, much like trying to use a straw with a crack in the side. This delicate assembly happens in the first few minutes of their adult life, a quiet moment of self-repair and preparation before the first flight. At this very moment, envision the visual world of the monarch, which is vastly different from our own. While we see the world through two lenses, the monarch uses two massive compound eyes, each containing approximately 12,000 individual units, called ommatidia. Picture this as having 24,000 tiny television screens, each showing a slightly different angle of the environment. This provides them with a nearly 360-degree field of vision, allowing them to detect the slightest movement of a swaying branch or a distant cloud. Furthermore, their vision extends into the ultraviolet spectrum. To a monarch, a white flower is not just white. It may have glowing, UV reflective patterns that act like a landing strip at an airport, guiding them directly to the nectar source. This ability to see hidden colors ensures they never waste energy searching for food in the wrong places. Scientists discovered that the monarch's navigation is remarkably similar to the way a pilot uses a flight computer. Deep within their brain, they process information from their time-compensated sun compass. This is not a simple aim for the sun instinct. Because the sun moves from east to west throughout the day, the butterfly's internal clock, located in its antennae, constantly recalibrates the heading. If it is 9 a.m., the butterfly knows the sun should be on its left to go south. By 3 p.m., it knows the sun should be on its right. This is as sophisticated as any GPS unit we carry in our pockets, yet it is contained within a brain the size of a pinhead. Deep within their eyes, there is another layer of navigation. They possess specialized proteins called cryptochromes, which are sensitive to the Earth's magnetic field. This means that even if a thick fog rolls in and hides the sun, the monarch can still feel the pull of the magnetic north and south. They are essentially flying with an integrated compass, a backup system that ensures the 3,000-mile journey continues, even when the sky is gray. This layered redundancy is a testament to the resilience of life. When one path is obscured, another reveals itself. Consider the texture of the chrysalis, the vessel of their transformation. If you were to find one hanging from a leaf, you would notice tiny shimmering gold spots on its surface. For a long time, people thought these were purely decorative, like jewelry. However, researchers have found that these spots, known as crown spots, are actually ports for respiratory exchange. They are the gateways through which the developing butterfly breathes. The chrysalis is not a dormant stone. It is a living, breathing chamber of change. Inside, the caterpillar's body actually breaks down into a cellular soup before rearranging itself into the complex form of the butterfly. This process, known as histolysis, is one of the most profound examples of biological recycling in the natural world. Everything is reused, nothing is wasted. As the monarch travels, it experiences the atmosphere in ways we can only imagine. They often fly at altitudes of up to 11,000 feet, where the air is thin and cold. At these heights, they are not just flying, they are surfing. Just as a surfer catches a wave to move toward the shore, the monarch catches mountain waves, updrafts of air created when wind hits the side of a mountain range. By positioning themselves at the leading edge of these waves, they can travel for hours without a single wing beat. This is the ultimate form of rest in motion. They are moving at 20 miles per hour while their muscles are completely relaxed, surrendered to the power of the wind. Notice how the monarch interacts with the world through its feet. On each of its 6 legs, the butterfly has sensory hairs and chemoreceptors that are 2,000 times more sensitive than human taste buds. When they land on a leaf, they are essentially smelling and tasting the plant's chemical makeup through their skin. This is vital for the female monarch, who must find the exact species of milkweed, such as Asclepias syriaca, to lay her eggs. She will drum her feet against the leaf to release the plant's juices, reading the chemicals to ensure it contains the right amount of cardenolides. These chemicals, while bitter, are what will make her offspring unpalatable to others. It is a protective inheritance, passed down through a simple touch. In the quiet hours of the afternoon, a monarch might participate in puddling. This is a behavior where groups of butterflies gather on damp soil or mud. They aren't just drinking water, they are mining for minerals. They use their proboscis to extract sodium and other essential salts that are not found in flower nectar. This is not so different from a long-distance runner drinking an electrolyte solution after a marathon. These minerals are crucial for their muscular function and their ability to remain in diapause through the winter. It is a quiet social moment, a gathering of travelers at a roadside spring, replenishing what the journey has taken from them. Picture the monarch's wings as a form of biological stained glass. The black lead lines are actually the veins filled with air and hemolymph, while the orange glass is the membrane covered in scales. These scales are made of chitin, the same durable, lightweight material found in the shells of sea creatures like shrimp or the exoskeletons of beetles. Chitin is incredibly strong for its weight, providing the butterfly with a toughness that belies its delicate appearance. When a monarch rests, it folds its wings together, and the scales interlock, creating a water-resistant barrier. Raindrops simply bead up and roll off, much like water off a well-waxed car. This keeps the butterfly dry and light, even in a heavy dew. The journey of the monarch is a testament to the power of small, consistent actions. They do not fly 3,000 miles in one burst. They fly, they rest, they eat, and they wait. They are in no hurry because their biology is perfectly synchronized with the planet's seasons. They know that the cold is coming, and they know the mountains are waiting. There is a profound sense of safety in this knowledge, a trust in the internal map that has never led their species astray. As you settle further into your own space, imagine your breath as a gentle updraft, supporting you just as the thermals support the Monarch. There is no effort required to stay afloat. Like the butterfly in the Oyamel forest, you are surrounded by a protective canopy. The temperature is settling, the light is fading, and your internal systems are slowing down, shifting from the activity of the day to the restorative pause of the night. You are clearing the metabolic waste of the day, just as the resting butterfly preserves its precious lipids. The world is vast and the journey is long, but for now, the only task is to be still, to be heavy, and to let the invisible currents of the night carry you toward a deep and effortless rest. The stars are out, the mountains are quiet, and you are exactly where you need to be. Consider the concept of a biological legacy, a story told in 4 distinct chapters across a single year. In our human lives, we often think of our journeys as personal, beginning and ending with our own experiences. But for the Monarch, the migration is a relay race across time itself. What's happening now is a profound handoff of information. 3 generations of monarchs live, fly, and reproduce within the span of a single summer, each living only 2 to 6 weeks. But the 4th generation, the one that makes the journey to Mexico, is different. Scientists discovered that this Methuselah generation undergoes a total physiological shift called reproductive diapause. By suppressing a specific chemical called juvenile hormone, JH, from their corpora allata glands, these butterflies stop the aging process in its tracks. This allows them to live for 8 or 9 months, becoming the silent guardians of their species' future. Not so different from the way we carry the traditions and stories of our ancestors, these butterflies carry a map they have never seen, yet know by heart. Notice how this biological pause mirrors our own nightly need for stillness. While the summer generations are busy and fleeting, the migrating generation understands the value of conservation. Deep within their tiny bodies, they are managing a metabolic budget that would baffle a financial planner. To survive the winter, they must maintain a delicate balance between activity and rest. Picture this: the Oyamel fir forests, or Abies religiosa, situated at altitudes between 2,400 and 3,600 meters, provide a unique microclimate. The air here is thin and cool, with high humidity that prevents the butterflies from drying out. Scientists have observed that within these groves, the temperature rarely fluctuates beyond a specific range. If it stays between 0 and 15 degrees Celsius, the monarchs can remain in a state of torpor. In this state, their heartbeats slow to a fraction of their normal rate, and their oxygen consumption drops significantly. They are essentially hibernating in plain sight, a collective of millions of lives held in a shimmering, orange suspension. At this very moment, imagine being one of those millions. There is a profound sense of social cohesion in the way they roost. They don't just land randomly. They cluster in densities so great that they can change the temperature of the air around them. A single Oyamel tree can host up to 50,000 butterflies. By clinging to one another, they create a living blanket. Just like us, seeking the warmth of a heavy quilt on a winter night, the monarchs use each other's body mass to buffer against the mountain chill. This behavior is more than just social. It is a thermal strategy. The scales on their wings, known as squamae, are arranged in such a way that they trap a thin layer of air against the wing membrane. This acts as a form of biological insulation, similar to the way a double-paned window keeps a house warm. Each butterfly is both a heater and a shield for the one next to it. Scientists discovered that monarchs also possess a specialized chemical defense against the cold. If the temperature drops toward the freezing point, Their bodies can produce cryoprotectants, substances like glycerol that act as a natural antifreeze. This prevents ice crystals from forming within their cells, which would otherwise be fatal. They can survive temperatures as low as -4 degrees Celsius, provided their wings remain dry. Consider the resilience required to wait out a mountain winter in such a fragile frame. It is a reminder that strength isn't always about force. Often, it is about the ability to remain still and endure. Notice the way the monarchs utilize sky islands. These are isolated mountain ranges that rise out of the desert or plains, providing cool refuges for moisture-loving species. The butterflies use these islands as stepping stones during their journey. When they finally reach the transvolcanic range in Mexico, they are not just finding a place to sleep, they are finding the only place on Earth that meets their specific biological requirements. This precision is astounding. The butterflies are guided by a combination of their sun compass and a magnetic sense. Deep within their brains, researchers have identified proteins called Cry1 and Cry2, or cryptochromes. These proteins are sensitive to blue light and the Earth's magnetic field, providing a constant directional pull that functions even when the sun is obscured by thick mountain fog. It is a navigational redundancy that ensures the legacy continues, no matter the weather. What's happening now is a beautiful synchronization with the planet's tilt. As the days grow longer in late February and early March, the monarchs begin to wake up from their reproductive diapause. The increase in daylight triggers the corpora allata to begin producing juvenile hormone once again. Suddenly, their biological clock starts ticking toward the next chapter. They begin to move, taking short flights to drink from mountain streams. This behavior, called puddling, is essential for replenishing the sodium and minerals they lost during the long winter. They use their tarsi, their feet, to sense the chemical composition of the damp earth, seeking out the electrolytes that will fuel their return journey. Picture this. As they prepare to leave, the butterflies engage in hill-topping behavior. They gather on the highest points of the mountain ridges, waiting for the perfect thermal conditions. They are like paragliders waiting for the wind. When the warm air rises from the valley below, they lift off in a massive orange cloud. This first leg of the return journey is taken by the very same butterflies that flew south months ago. They will fly into Texas or the southern United States, find the first emerging milkweed, lay their eggs, and then their long life will finally come to a peaceful end. They have fulfilled a promise made by their great-grandparents. Just like us, the monarch's life is a series of interconnected phases. We tend to focus on the doing, the flying, the eating, the traveling. But the being, the long months of quiet in the Oyamel firs, is what makes the flying possible. Without that period of profound rest and chemical suspension, the species would vanish. Their diapause is not a waste of time. It is a concentration of life. It is an investment in the future. At this very moment, as you lie still, you are making a similar investment. Your body is performing its own version of diapause, slowing down your heart rate, regulating your core temperature, and shifting your focus from the external world to the internal restoration that only sleep can provide. Notice how the monarchs are members of the Nymphalidae family, a group of butterflies known as brush-footed butterflies. This is because their front pair of legs is vestigial, small and tucked away, leaving them with only 4 functional legs for walking. Even their anatomy reflects a simplification, a shedding of what is not strictly necessary for their primary goal, flight and survival. In the quiet hours of the night, we too can shed the unnecessary. We can fold away the worries of the day, the lists of tasks, and the physical tension we carry in our muscles. Like the monarch's vestigial legs, those concerns have no function in the state of rest. Scientists discovered that the monarch's wings are covered in approximately 12,000 microscopic scales per square inch. Each scale is a single cell, pigmented or structured to reflect specific wavelengths of light. During the winter, these scales can become slightly duller as the butterfly ages, but their structural integrity remains. They are a testament to the durability of the small. If we could watch a monarch resting on a branch, we would see that it is never truly stagnant. Its antennae are always slowly moving, tasting the air for changes in humidity or the scent of nectar from a distant valley. They are always present, always attuned to the rhythm of the forest. Consider the metaphor of a great library. Each monarch is a book, but the story of the migration is only completed when the library is read from beginning to end by 4 different readers. The 4th reader, the Methuselah butterfly, carries the heaviest responsibility, yet it is given the longest life to ensure the book is returned to the shelf. There is a profound peace in knowing that we are part of something larger than our individual days. We are part of a cycle of seasons, a rhythm of work and rest that has been refined over millions of years. As the shadows deepen in the Oyamel forest, the sound of the wind through the fir needles is like a soft collective sigh. The butterflies are secure. They are tucked into the crevices of the bark, clustered together in a mosaic of orange and black. They are not afraid of the dark, for the dark is where they find their strength. They are not anxious about the journey north, for their bodies are already prepared for it. They are simply existing in the now, a state of perfect biological equilibrium. You are entering that same grove of stillness. The cool mountain air of your own room is settling around you. Your breath is becoming a slow, rhythmic pulse, not so different from the metabolic hum of the resting colony. The weight of your limbs is like the heavy branches of the fir trees, sagging comfortably under the weight of the day. You are clearing the cellular debris of the day, resetting your internal compass for the morning. But for now, there is no south, no north, no 3,000-mile trek. There is only the canopy, the quiet, and the deep, restorative pause of the night. Like the monarch, you are exactly where you need to be to ensure that your own story continues, refreshed and renewed, when the sun finally touches the trees. Notice how the forest in Michoacán carries its own specific acoustic signature, a sound unlike any other place on Earth. In the quiet hours of a mountain morning, if you were to stand perfectly still among the Oyamel firs, you would hear a sound like the lightest rainfall or the softest rustle of silk. This is the collective movement of millions of pairs of wings, a phenomenon scientists call the whisper of the monarchs. Each wing beat produces a low-frequency vibration of about 10 to 12 hertz, a sound that is almost below the threshold of human hearing, but can be felt as a gentle thrumming in the air. This sound is the result of air rushing over those thousands of microscopic, chitinous scales. Consider the monarch as a living solar panel made of velvet dust. Each scale is a tiny shingle-like plate that not only provides color, but also manages the butterfly's relationship with heat and sound. What's happening now is a sophisticated exercise in thermodynamics. Scientists discovered that the orange and black patterns on a monarch's wings are not merely for display. They play a critical role in thermoregulation. The black veins and borders are highly efficient at absorbing solar radiation, heating up more quickly than the orange patches. This creates tiny temperature gradients across the wing surface, which may help stimulate the flow of hemolymph through the veins. At this very moment, as the first light of dawn filters through the Abies religiosa canopy, the monarchs are performing a ritual of shivering. They vibrate their flight muscles without moving their wings, a process of myogenic heat production that raises their internal temperature above the ambient mountain air. This is not so different from how we might rub our hands together to stay warm on a crisp autumn evening. Picture this. The sensory world of the monarch is a tapestry of chemical signals and light. While we perceive a limited spectrum of colors, the monarch's compound eyes are equipped with specific proteins called opsins that allow them to see into the ultraviolet. To a monarch, the world is a glowing map. Scientists discovered that the flowers they visit, like the senecio or the wild asters, possess UV nectar guides, hidden patterns that act like neon signs pointing toward food. This ensures that the butterfly, which has a brain weighing less than a milligram, never wastes precious energy searching an empty bloom. Their vision is also highly sensitive to the polarization of light, allowing them to detect the orientation of the sun even through a thick gray blanket of mountain fog. They are essentially perceiving a celestial geometry that is invisible to us, a constant blue sky compass that guides them even in the dark. Deep within the base of their antennae lies an organ of incredible sensitivity called the Johnston's organ. This is the butterfly's primary flight instrument, a cluster of sensory cells that detects changes in wind speed and air pressure. As a monarch glides through the thin air at 3,000 meters, this organ provides constant feedback, allowing the butterfly to adjust the pitch and yaw of its wings to maintain a perfect glide. It is a biological equivalent of an altimeter and an airspeed indicator combined. Scientists have discovered that these butterflies are so sensitive to barometric pressure that they can sense a distant storm system hours before it arrives. When the pressure drops, they instinctively tighten their grip on the fir needles, tucking their abdomens close to the bark to reduce their profile against the wind. Notice the scents that define this high-altitude sanctuary. The Oyamel forest smells of damp earth, cold stone, and the sharp, resinous perfume of the fir needles. For the monarch, however, the olfactory landscape is even richer. Using the chemoreceptors on their antennae, which can detect a single molecule of a specific scent amidst billions of others, they smell the humidity of a nearby stream and the pheromones of their kin. Scientists discovered that male monarchs possess specialized scent patches on their hind wings called androconia. In many butterfly species, these patches release pheromones to attract mates, but in the migrating monarch, these glands are often dormant. They are saving their chemical energy, expunging metabolic byproducts through their spiracles, and maintaining a state of purity for the long wait. Consider the physics of the blanket and umbrella effect provided by the forest canopy. At this very moment, the temperature outside the grove might be dropping toward freezing, but inside the dense stand of Oyamel firs, the air remains several degrees warmer. This is due to convective cooling, being blocked by the needles, and radiative heat being trapped by the forest floor. Scientists discovered that the humidity within these groves often approaches 100% at night. This is vital because monarchs, like all insects, lose moisture through their spiracles. The damp mountain air acts as a biological humectant, preventing the butterflies from dehydrating during their long months of fasting. They are encased in a womb of mist and wood, a perfect microclimate that has existed for millennia. What's happening now is a deep dive into the butterfly's internal chemistry. To survive the winter, they rely on a process called lipid loading. Before leaving the north, they consume vast quantities of nectar, converting the sugars into a specialized type of fat called triacylglycerols. These lipids are stored in the fat body, a multifunctional organ in the abdomen that acts as a combined liver and adipose tissue. During their stay in Mexico, they burn these fats at an incredibly slow rate, less than 0.1 milligrams per day. By keeping their body temperature just above freezing, they ensure that their metabolic engine stays in idle, much like a car parked in a garage during a cold winter, its battery preserved for the spring start. At this very moment, imagine the sensation of being part of a cluster. As millions of butterflies hang together, they create a collective thermal mass. Scientists have used infrared thermography to visualize this, showing that the center of a large cluster can be significantly warmer than the outer edges. The butterflies on the outside act as insulators, and throughout the night, they may slowly shift positions, a quiet democratic movement that ensures no single individual is left too long in the cold. It is a heartwarming example of biological cooperation, a reminder that even in the insect world, there is a strength in numbers that transcends the individual. Notice the texture of the fur needles under the butterfly's tarsi. The Abies religiosa has soft, flat needles that are perfect for gripping. The monarch's feet are equipped with 2 tiny claws and a sticky pad called an aerolium, which allows them to cling to almost any surface with minimal effort. This passive grip means that when the butterfly is in a state of torpor, its muscles don't have to work to keep it from falling. Much like a bird whose tendons lock its feet onto a branch as it sleeps, the monarch is locked into its sanctuary. It can remain suspended through mountain gales and heavy rains, a tiny, resilient anchor in a moving world. Scientists discovered that the monarch's immune system also shifts during this period. While in diapause, they produce higher levels of certain antimicrobial peptides, protecting them from fungi and bacteria that thrive in the damp forest. They are not just resting, they are maintaining their cellular integrity, clearing metabolic waste through a slow but steady internal process. This is not so different from the way our own bodies perform essential housekeeping during our deepest stages of sleep, repairing tissues and reinforcing our defenses for the day to come. Picture the internal aquarium of the butterfly. Their circulatory system is open, meaning their hemolymph doesn't stay in vessels, but bathes their organs directly. This hemolymph is rich in a sugar called trehalose, which provides a steady, dawn, slow-release energy source for their nervous system. Unlike our blood, which uses hemoglobin to carry oxygen, the butterfly's hemolymph primarily moves nutrients and hormones, while oxygen is delivered through the network of tracheal tubes. This decentralized system is incredibly efficient for a small creature, allowing for rapid gas exchange when they fly and minimal energy loss when they rest. Notice how the colors of the monarch, the deep burnt orange and the jet black, serve as a warning to the world. This is aposematism, a biological signal that says, "I am not a meal." The cardenolides they sequestered from milkweed as caterpillars are now concentrated in their wings and exoskeleton. Scientists discovered that these toxins are particularly bitter to the taste buds of birds. This chemical shield is what allows them to rest in such massive, conspicuous numbers. They don't need to hide in the shadows because their very beauty is their armor. They can sleep in the open, draped over the trees like royal tapestries, protected by the memory of the milkweed. As you consider the complexity of this tiny traveler, feel your own senses beginning to soften. The sharp details of the day are fading into a more generalized, peaceful hum. Like the monarch sensing the drop in pressure, you are recognizing that the time for movement has passed. Your room is your Oyamel forest, a place of controlled temperature, soft textures, and safety. The internal work of your body is continuing, but the external demands are gone. You are part of the same planetary rhythm that calls the monarchs to the mountains. It is the rhythm of the seasons, the rhythm of the sun, and the fundamental biological requirement for a long, undisturbed pause. Deep within the forest, the whisper of the wings is slowing as the temperature drops another degree. The mist is thickening, wrapping the trees in a silver veil. The monarchs are still, their antennae tucked, their metabolic engines purring at the lowest possible setting. They are waiting for the sun, but they are not impatient. They are simply existing in the perfect, cold, damp peace of the Michoacan night. You are drifting toward that same equilibrium, where the air is cool, the blankets are heavy, and the journey is momentarily suspended in the beauty of the quiet. Notice how the mountain air in the Oyamel forest begins to shift as the calendar turns toward the vernal equinox. What was once a static, frozen landscape of orange and black is now entering a phase of gradual rhythmic awakening. The process begins not with a sound, but with the subtle lengthening of the days. Scientists discovered that the monarch's internal circadian clock, housed in its antennae, is attuned to the photoperiod, the specific duration of daylight. As the sun climbs higher in the sky each day, the increasing light intensity signals the butterfly's endocrine system to resume its work. Specifically, the corpora allata, two tiny glands located behind the brain, begin to secrete juvenile hormone once again. This chemical signal acts as a biological on switch, ending the long state of reproductive diapause that has kept the butterflies in a youthful, non-aging state for nearly 9 months. Picture this: as the hormone levels rise, a sequence of events unfolds within the butterfly's body. First, their metabolic rate increases, requiring them to seek out hydration. You would see them descending from the heights of the Abies religiosa trees, moving in a slow, shimmering cascade toward the mountain streams. This process is called drinking the dew. They gather by the thousands at the water's edge, uncoiling their proboscis to sip the cool, mineral-rich water. This hydration is the second step in their preparation for the journey north. Following this, the reproductive organs, which have been dormant all winter, begin to mature. For the first time since they emerged from their chrysalides in the fields of Canada or the American Midwest, the Methuselah generation feels the drive to find a mate and continue the lineage. The departure from the Mexican highlands is not a sudden exodus, but a measured, step-by-step transition. Scientists have observed that the butterflies wait for a specific thermal threshold, usually around 13 to 15 degrees Celsius, or roughly 55 to 60 degrees Fahrenheit, before they can sustain long-distance flight. Notice how they spend their mornings basking, spreading their wings flat against the sun-warmed bark of the fir trees. They are essentially charging their biological batteries, using their wings as solar collectors to raise their thoracic temperature. Once they reach the necessary warmth, they lift off, catching the rising thermals that will carry them out of the valleys and toward the north. What's happening now is a remarkable reversal of the path they took months ago. Unlike the southern migration, which is a slow, soaring glide focused on energy conservation, the journey north is more urgent. They are following the green wave, the gradual emergence of milkweed plants across the southern United States. They enter the Veracruz Flyway, a narrow corridor between the mountains and the Gulf of Mexico, where the wind currents are most favorable. At this very moment, as the Methuselah generation crosses into Texas and the Gulf Coast states, they are scanning the landscape with their compound eyes, searching for the specific chemical signature of the Asclepias genus. Consider the precision of the egg-laying process. Once a female finds a suitable milkweed leaf, she performs a test using the chemoreceptors on her legs. She drums her feet on the leaf to release its juices, ensuring it contains enough cardenolides to protect her offspring, but not so many that it becomes toxic to the tiny larvae. Then, she curls her abdomen and deposits a single, creamy white egg on the underside of the leaf. This placement is a deliberate step to protect the egg from desiccation by the sun and from being washed away by spring rains. A single female may lay between 400 and 500 eggs over the course of several weeks, placing each one with meticulous care. As the Methuselah generation completes this final task, their long and extraordinary journey comes to a peaceful conclusion. They have lived 8 times longer than any other generation of their kind, surviving mountain winters and continental crossings. Not so different from a runner passing a baton in a relay race. They hand off the future of their species to the next generation. The eggs they leave behind will hatch in just 3 to 5 days, beginning a new cycle of life. The tiny caterpillars will go through 5 stages of growth, called instars, shedding their skin each time as they prepare for their own transformation. Deep within our own biology, we share this need for cyclical renewal. Just as the monarch's journey is governed by the light of the sun and the internal timing of its brain, our own rest is regulated by the suprachiasmatic nucleus, a tiny region in the hypothalamus that manages our circadian rhythms. As you lie here, your body is entering its own overwintering phase, a period of profound restorative work that is just as complex as the butterfly's diapause. At this very moment, your pineal gland is releasing melatonin, a hormone that signals every cell in your body that the time for activity has passed and the time for repair has begun. Notice how your breathing has become a slow, rhythmic ebb and flow, mirroring the gentle pulsing of a butterfly's wings in the Oyamel forest. Your heart rate is slowing, and your core body temperature is dropping by a degree or two, a biological cooling that is essential for entering the deeper stages of sleep. Scientists discovered that during this time, our brains engage in a process similar to the monarch's metabolic housekeeping. The glymphatic system, a recently discovered biological plumbing network, becomes highly active during deep sleep. It works to evacuate metabolic byproducts that have accumulated throughout the day, clearing the neural pathways so that you can wake with a fresh and clear mind. What's happening now is a transition into N3, or slow wave sleep. This is the most restorative phase of our night, where the brain produces high-amplitude delta waves. Just as the monarch's body repairs its wing muscles and regenerates its lipid stores during its winter rest, your body is currently secreting growth hormones to repair tissues and strengthen your immune system. You are not simply off. You are in a state of active, quiet reconstruction. You are preparing for your own migration back into the waking world, ensuring that when the sun rises, you have the energy and clarity to navigate your day. Consider the sense of safety that comes from being part of these ancient planetary rhythms. The monarch does not worry if the milkweed will grow. It trusts the season. It does not fear the long flight north. It follows the map written in its very cells. You can have that same trust in your own body's ability to rest. You don't need to force sleep any more than a butterfly forces the spring. It is a natural unfolding, a process that happens when you simply stop resisting the pull of the night. As we submerge into this final stage of repose, feel the connection between your rest and the rest of the natural world. The forest in Mexico is quiet now, the butterflies tucked away in their shimmering clusters. The fields of the north are waiting for the first orange wings to appear. Everything is in its right place. The journey is being handled by forces far older and wiser than our daily worries. You are held in the same cradle of biology that carries the monarch across a continent. Notice the weight of your limbs, like the heavy, snow-dusted branches of the Oyamel firs. Let that weight pull you deeper into the mattress. There is no more distance to cover, no more nectar to find, No more maps to read. The stars are moving in their slow, silent arcs above you, and the world is turning toward the dawn. But that dawn is a long way off, and the night is vast and kind. As you drift into the quiet, carry these affirmations with you. I am at peace with the rhythm of the night. My body knows exactly how to restore itself. I am safe, I am supported, and I am exactly where I need to be. Like the butterfly in the forest, I trust in the coming of the light, but for now, I embrace the beauty of the dark. The air is cool, the blankets are warm, and your mind is as still as a resting wing. The journey of the Monarch has taught us that even the most fragile life is capable of incredible things when it honors the need for rest. You have done enough for today. The legacy of your day is being stored away, and the promise of tomorrow is being prepared in the quiet of your dreams. Surrender to the stillness now. Let the whispers of the forest fade into the background. The migration is paused. The mountains are silent. The world is asleep. Good night.